together will give you the ability to test really a wide range of business logic. Up until today, we hadn't been able to test calculations with the previous 4, but now we've got a tool that will be very useful when we've got complex calculations. So this really covers the black box stuff, and then in some of the subsequent advanced webinars, we'll move on into some more of the white box techniques and see how those can help us. Okay, so let me put the advertisement up as usual, and we move into question and answer session. Let's see if some of you have got some questions here. Get the question and answer box undocked. Okay, and a question via email. What's the difference between boundary value analysis and equivalence partition testing versus domain analysis? I mentioned that at the beginning, and since I've gotten that question, then I wanted to save that discussion here, so I'll cover that. You could say, and some people do say, that basically in domain analysis you are extending the concept of the of equivalence partitioning and boundary values into a continuous space, if you will, from a single dimension into multiple dimensions. So you'll sometimes hear it called that, multidimensional equivalence partitioning or multidimensional equivalence partitioning and boundary value analysis, because that's what we're doing. And you notice that, right? I mean, you think, okay, the in and out values, all right, those are members of what is essentially an equivalence partition. The equivalence partition in the aerospace example was created by the time elapsed since the measurement. And in the case of the frequent flyer, the equivalence partitions were created by either your status or the total distance that you traveled, in which case that determined your status. So they are very closely related, and you know, some people would say there's actually no difference. It's just extending the concept out further. And you know, if you want to think of it that way, and you want to say, you know, I don't want to worry about any of this on, off, in, out stuff. I just want to look at the boundary values and equivalence partitioning on these calculations, then I'm certainly not aware of any reason why that wouldn't work. You certainly could do that. I'm not sure if you tried to extend that into the application of that concept on the decision tables, if that would work as well. You might want to check out my discussion on domain analysis and pragmatic software testing, and then see if you think that, see if you can still extend it into that situation. Let's see, another question via email. So like equivalence partitioning and boundary value analysis, then domain analysis has some implications for code coverage. Yes, there are code coverage implications. So you remember that if you look at you look at equivalence partitioning and you look at boundary values. So in equivalence partitioning, basically you've got separate chunks of code that correspond to the equivalence partitions, right? Because the equivalence partitions are things that are handled the same, and so each partition is of course handled differently, and so that means that there has to be a different block, at least one different block of code associated with each equivalence partition. And so to get equivalence partition coverage, you'd have to necessarily get statement coverage at least for the blocks that corresponded to the equivalence partitions that you were looking at. And then boundary values, what you're testing there effectively are the conditions, either the switch case construct or the if construct, or the conditions in the if, that are determining the selection of the block of code. So you know, there's a relationship with decision coverage, and in some cases possibly condition coverage, though you wouldn't necessarily be guaranteed to get 100% condition coverage by any means, just because you got the boundary values. But there is clearly a sort of a direct relationship between covering the domain values and covering the different the blocks of code and the decisions that determine the blocks of code to be selected to do the calculations, just as there would be in the case of the equivalence partitions and boundary values. So yes, there's a strong analog there, and certainly something worth being aware of. Okay, question from Mark. Mark asks, the presentation is available online. Yes, the presentation, if you go to www.rbcs-us.com and go to the resources tab, which will be visible the sort of middle top-ish of the page, go to resources tab and then go to the basic library and go to the very bottom of the basic library. You should be able to find the presentation. Chase asks, how is the smallest recognizable amount determined for an off value? Well, ideally, it would be determined in a design specification somewhere, whether high-level or low-level design specification. But we'd have some way of determining what that smallest recognizable amount is. Worst case, it's determined by the values being used to store the variable. And I say worst case because then that can be the smallest recognizable amount can be something that varies depending on where we are in the range. So, you know, I don't want to get into too much detail here because this isn't one of the white box discussions, but if you've got a floating point number, the number of bits of precision, if you will, remain the same, but the relationship between that precision and the decimal point can change. Because if you're dealing with a very large number, let's say we get a floating point variable and we store a number that's, say, you know, in the quadrillion range in it, you still have the same number of bits of precision, but you run out of precision long before you get to the decimal point. Versus when that number gets to be down below 1, then you have the same number of bits of precision, but they're all on the other side of the decimal point. So that what is the smallest recognizable difference between some fixed value and some variable value that's stored in a floating point number? Well, it depends on the value of the floating point number at that time. So not a happy situation, and what you want, as I said, is you want to have some sort of design specification that's actually helping to tell you what that smallest recognizable difference is. The good news here is if you can't find it in the design spec, that probably means that there hasn't been a lot of thought put into this, and it's a great opportunity to go and talk to the programmers about this and say, well, what's the smallest recognizable difference between values here? And then they say, well, you know, it depends. And then if they say that, then this is you need to tell them this is a classic way of having numerical analysis bugs in your code. And if they still don't get that, then you want to start running a lot of tests in those areas when you get the code. Now, numerical analysis is a really complicated field, and I mean, I spent, when I was going to UCLA, I spent a whole 10 weeks on a numerical analysis class, and I remember that as being one of the more intellectually challenging classes of my entire time there. That and upper division statistics were the two that just about made my brain bleed every time I was in the class. But I would say, if you're testing complex applications that do complex floating point mathematics, one thing you have to do is get really up to speed on how floating point numbers are stored, and then I would also recommend that you pick up a textbook on numerical analysis and read it up, because as a tester, you're going to find a lot of bugs there. It's a very complicated subject. It's hard to program properly, and anything that's hard to program properly, as we know, is a field of dreams when it comes to bugs. All right, I got a question from Doug. Doug, good to see you back.